I've now had an opportunity to play with the Revision 1 hardware for a few days, and in general I have to say I'm pretty pleased with it. It does what I want, and I'm in this situation now where I can start writing some serious software. But there's a few things, if I was looking at a Revision 2, that I would change. This LED, I want to move slightly closer to the clock out port, and I'd also like to, at the moment I'm driving it from a GPIO pin, I'd like to change that so that it's actually physically driven from the clock out, and that would win me back a GPIO pin that I could use for something else. And that something else is this switch here, the algorithm switch, which at the moment it's just a 4-way switch, 1, 2, 3, 4, and that gives me 4 different algorithms. But if I win this GPIO pin back, I can turn that into an 8-way switch, and that I think would give me some benefits, a bit more flexibility. And the other thing is that on a potentiometer where you've got a round shaft, it really doesn't matter, because you can put the knob on any which way you like. So this one, it's pointing down in this direction. I can turn it round, and that's the kind of normal orientation for indicators on a potentiometer. But if the shaft is a D shaft, then you can't do that. You're kind of limited to whichever way the D points. So on this one, for example, when I attach a knob to it, the indicator is pointing up in this direction, and I can turn it 7 ways round. But that means that the indicators really need to be on the right hand side around here, and that doesn't feel right. So I really need to turn the orientation of this multi-way switch by 90 degrees. And again, this potentiometer, if I attach a knob to its D section shaft, then clearly it really needs to be the other way up, so that its orientation is inverted by 180 degrees. So there's a few physical things that I need to change, and there are a number of changes I'd like to make to the schematic, to the circuit diagram. And one of them is I need to correct the error I made on the Revision 1, which is that I'd for some reason put the LED output on GPIO 7 and the data input on GPIO 11. I need to correct that. And whilst I'm at it, I'm going to drive the LED, the clock out LED, electrically from the clock out GPIO pin, and that means I can win back a GPIO pin, which means that I can move the algorithm switch from a 2-bit binary input to a 3-bit binary input. So move it from a 4-way to an 8-way algorithm, and I think that will give me a bit more flexibility. On the Revision 1 hardware, I used an MC14532 to convert or encode the 8-way rotary ratio switch into 3 lines of binary coded decimals, so 3 GPIO pins to encode an 8-way switch. Whereas for the algorithm switch, I just used diodes to encode a 4-way switch into 2 GPIO pins. So if I want to move the algorithm switch to an 8-way switch, I'm going to have to put in a second 14532 8-bit priority encoder. Another change I want to make, I've got 2 switches. One is the multiply divide switch, and the other is the sync free running switch. And this one, internal pull-up resistor, and the switch pulls it to ground, and this one internal pull down resistor and the switch pulls it up to 3.3 volts. Monkeys with my OCD, so I'm going to change this one so that it's the same as the sync-free switch, so that an internal pull-up resistor and the switch pulls it down to ground. As I mentioned, I'm currently using an LM1117 5-volt regulator, and that has the big tab on the output, on the 5-volt output, but I want to change that to a 7805, which has the big tab physically on a DPAC package on the ground connector, and so that means I'm going to have to change the layout of the board around here. So instead of a large tab on the 5-volt, I'm going to have a large tab on the ground, and that means I can put some thermal wires through in this kind of area, so jiggle things about a bit. Finally, on the board interconnects, I'd needed to route the 3.3 volt rail between the two halves of the PCB, and so I'd scattered another couple of connectors around, thinking, okay, that will improve my connectivity. But actually, when you then look at the resulting PCB, and I've highlighted the 3.3 volt net, I've actually got connectors going down, or I've got traces going down to these connections here, purely so that I can route things between the two halves of the board. And that just adds to the complexity and doesn't really buy me anything, so I'm going to simplify that kind of board interconnect as well.